In the first section of Chapter 2, we talked about how to solve quadratics. We were reviewing some things from Algebra 1, Algebra 2. Now we're going to look at the graphs of quadratics. And the name of the graph of a quadratic is called a parabola. And remember, they either look like this, or they can look like this. So they're either a happy face or a sad face. Now, remember our equation of a quadratic, ax squared plus bx plus c. And if we're looking at the graph of it, we're looking at all the y values that meet those conditions. So it's giving me a set of points, and they do form this quadratic. Now, how could I tell which way the parabola is going to open? Let's see how many remember that. Oh yeah, it's that leading coefficient, that a. So if a is positive, if you're positive, you're going to be happy. So you opens up, be happy face. And if a is negative, it opens down. That's not how you spell open. Opens down. Now the vertex of a quadratic. The vertex is that point where it's turning around. And the x value of the vertex, there's a simple formula that actually allows us to find it. So to find the vertex, the x coordinate is found by negative b over 2a. And that should look kind of familiar. That's actually, if you looked at the quadratic formula, that's everything that's not in the square root. So negative b over 2a. That will find the x value of my vertex. Now, how would I find the y value that goes with it? Well, the y coordinate would just be f of negative b over 2a. In other words, I would just plug that x value in. Now, while we're on the vertex, I want to talk about their locations. So notice that we're going to be finding the vertex. So here's our formula for finding it. And we're going to determine whether that vertex is a maximum or a minimum. Well, let's think about this, okay? So if it's opening up, what would you call that vertex? Well, that's a min. It's at the bottom. And if we're opening down, my vertex would be a maximum. Now, there's another key feature. It's called the axis of symmetry. And it's what this imaginary line that cuts down the middle of a quadratic. That's called an axis of symmetry. Axis of symmetry. And what's really nifty about it is it's a vertical line. So that means it's an x equals line, and it's going straight through the vertex. It's actually just going to be x equals whatever that x value is. So once you know your vertex, you know your axis of symmetry because they're connected. Let's practice it. So here's a quadratic. F of x equals 2x squared minus 4x plus 4. The first question I'm going to ask you is, which way is this graph going to open? Well, since 2 is positive, a is positive, this is going to open up. The next thing we want to know is our vertex. It's really, really important. So we can get our vertex. So we're going to find the x coordinate of the vertex by negative b over 2a. So x is going to be, so this is finding the vertex. X is negative b over 2a. So b is negative 4, so that means I'm going to have negative 4 over 2 times a. So I've got, that's negative, that makes it positive 4 divided by 4. That's going to be a 1. Now to find the y value, that's just going to be f of 1. In other words, I'm just going to plug 1 into my function up here. So 2 parentheses 1 squared minus 4 times 1. And you're welcome to use a calculator to evaluate this, but it gives me a 2. So my vertex is at 1, 2. Now we can find some other points that help us graph it really well, and that would be like plugging in maybe, let's plug in some other points so that we can graph it. And you can look at the table of your calculator, but one easy place to go to graph it would maybe to pick some points around the vertex. So pick like 0 for x, and maybe we already know 1 goes to 2. Maybe pick 2 and plug those in. Well, 0 is super easy to plug in, so I'd have 0, 0. I'd end up with a 4. And I'll show you something neat. Okay, so if this is symmetric, okay, so symmetric, and we're going one spot over from the vertex and one spot over. If this one has a y value of 4, so will this one. So my vertex is at 1, 2. I'm cutting through 0, 4, and 2, 4. And that's 3 points. That's enough to get an idea of how wide this graph is or how narrow it is. And so we can kind of sketch the graph. And is this vertex a maximum or a minimum? Well, I can tell it's at the bottom of the graph, so this is a minimum. Also, what would be the axis of symmetry? Well, it would be this vertical line going straight through there, so it's going to be x equals 1. It's going to be the same x value that we found here. So it's x equals 1. Profit function. Oh, we're jumping right into an application. They're giving us the function for profit. And we want to find the number of units that will give a maximum profit. And we want to find that maximum profit. See how that can be really useful for a business. Now let's think about which way this graph is going to open. So since A is negative, this opens down. So my graph is going to look like this. So I definitely will have a maximum, right? Max. So I just need to find that point. And that point is my vertex. So I need to find the vertex. So x equals negative b over 2a. So let's see. B is 300 over 2 times negative 0.1. So I've got, and I'm going to alpha y equals to give me a fraction, negative 300 over 2 parentheses negative 0.1. And it gives me 1500. But that's just giving me the x value. That's just the number of units. So this is the number of units. I also want to know the profit at that point when we sell 1,500 units. So I'm going to go ahead, and there's a couple of ways I can do this. I can plug 1,500 in directly, and that's what I think I'm going to do in this one. Negative 0.1 parentheses 1,500 squared, because it's going in for x, plus 300 times 1,500 minus 1,200. And I get that we have a maximum profit of $223,800 when 1,500 units are sold. Now we're going to look at a little bit more about the graphs. So the next part is that we want to know about the zeros of the quadratic function. Now just remember, zeros of anything mean the x-intercepts. We're called zeros because it makes f of x equals 0 or y equals 0. These are our x-intercepts. So let's review a little bit. Okay, we have this form of a quadratic. If a is positive, the parabola is opening up. And if it opens up, my vertex is a minimum. If a is negative, it opens down, and my vertex would be a maximum. I'm going to find the vertex using x equals negative b over 2a. And I'll find the y value by just plugging that number into f. That also gives me my axis of symmetry. Now the new thing we're adding are intercepts. So x-intercepts, or zeros, just mean I'm going to set my function equal to 0 and solve. Y-intercept is super easy. That's when x is 0. Which, guess what? When I let x be 0, it's always going to be that constant at the end. And if you think back, mx plus c, whatever the plus c or plus b at the end, when it's just a constant, that is my y-intercept. So we're going to just graph a few, and we're going to get a little bit more involved. So on this function, determine whether the vertex is a maximum or a minimum, find the coordinates of this point, and find the zeros if they exist. Sometimes you don't have x-intercepts, like that first example. Notice we had a y-intercept, but we did not have any zeros, no x-intercepts. All right, so y equals 4x minus x squared. So let's first off, it's kind of not in order, right? I would much rather it be negative x squared plus 4x. And normally there's a plus c, so that c is 0, right? Okay, plus 0. Now it says, is the vertex a maximum or minimum? So a is negative. So this opens down. So what do I know about the vertex? The vertex is, if it opens down, vertex is a maximum. Then it says to find the coordinates of the vertex. So we've done that. We need to do x equals negative b over 2a. So that's going to be negative 4 over 2 times negative 1. So that's a negative 4 divided by negative 2. That's going to be a 2. And I just need to plug it in to my original function. And I get a 4. So my vertex is at 2, 4. Now it says find the zeros. And the zeros are when the function equals 0. So I had, let's put a little boundary line here. So negative x squared plus 4x, we want to know when that equals 0. Let's see, they both have an x. I could factor out an x, or even a negative x, I could. Negative x. And that would leave me with x minus 4, because negative x times negative 4 would be 4x. Set each factor equal to 0. And so again, I have now 3 points. I have my vertex is at 2, 4. I have one x-intercept, so these are my x-intercepts, is at 0, and the other one is at 4. That's giving me enough to connect. You could find more points if you want to be more accurate, but when they say sketch, that's enough. All right. For the function y equals 7 plus 6x minus x squared, we're going to do the same thing. So feel free to pause the video, try it, then come back. I'm going to rewrite it in order. A is negative. Vertex is a maximum. Ooh, that one just kind of went off the page, didn't it? Oh well, it's okay. Ooh, I'm going to divide both sides by a -1. And you can do that because as long as you do to one side what you did to the other, you're okay. So this would give me a positive x squared minus 6x minus 7 equals 0. So I know the 16 is off the page. I'm sorry about that. 5, 10. It'd be way up here. And then the 1. Oops, I'm sorry. -1. That is not the right point. And 7. And we have a sketch. You could also be using your calculator to help you sketch. All right, now we're going to look at a little bit more of a real-life application here. We're going to also be talking about average rate of change too. So, Ace Cruises offers a sunset cruise to a group of 50 people for a price of $30 per person, but it reduces the price per person by 50 cents for each additional person over 50. Okay, so I want you to think about this. So, let's think about, because if we're talking about the revenue, we're going to find the revenue is going to be the price times the number sold, right? Okay, so the price is how much? So this is going to be revenue. So we're going to be an R of X. Okay. So the revenue. So what's the price starting out? The price is $30. And it's going down by 50 cents for each additional person. So X is going to be the number of additional people over 50. Okay. Because it's 50 cents times the number of additional people over 50. Now we need to know how many tickets are sold. Well, it's 50, because it's a group of 50, plus however many extra you have. And so we want to know will reducing the price per person get more people to come in? So would it? Let's see. Will it bring in more money? So we could actually make a little table, and if we had no increase, so our x's, so let's do a quick table. And I'm actually going to go ahead and let's multiply that out. Let's multiply it out so we can put it in the calculator a little bit easier. That's going to be 1,500. And then 30x, and then negative 25x, then negative 0.50x squared. So my revenue function is going to be negative 0.50x squared plus, let's see, that makes it a 5x plus 1,500. And I'm actually going to use my calculator. You can also do this in Desmos if you prefer, to make a little table real quick. And I'm going to go to the table, so second table. So if we don't change the price at all, 30 people, and 50 people at $30 a price, it's 1,500. Now, if we go up to, let's see, we have 5 additional people. We are at $1,512.50. So, is it, let's see, and then let's see, and then if we have 8 people, it's at 1,508. So, the price, the revenue goes up, but then it starts going back down, right? At 10 extra people, we're back at $1,500 for revenue. Let's see what happens after that. Ooh. It starts to lose money. So let's see. We had 50 people. We can get up to, if there are more than 60 people, the revenue will decrease. But between 0 and 10 extra people, so between 50 and 60 people, the revenue will increase. How many people will provide the maximum revenue? Well, that's going to happen at that vertex, right? So that's going to happen when x equals negative b over 2a. So my b is 5, so that's negative 5, over 2 times negative 0.50. And you can use your calculator. Negative 5 over 2 parentheses negative 0.50. And it's 5. Ooh, which was actually in our table. So 5 people provides the maximum revenue of 15, 12, 15. Wait, it's not just 5 people, right? That's 5 extra people. So how many total people are going to be on the cruise to get a maximum? That means total of 55 people. Not just 5 people. That wouldn't even make sense. Okay? Given this last example, what is the average rate of change of revenue if the group increases from 50 to 55 people? So what we're wanting to look at is the change in revenue over the change in people. So what was the revenue at 55? Well, that was 1512.50. And the revenue for 50 people was 1,500. And that's 55 minus 50 people. So that's really going to be, what, 1250 divided by 5? $2.50 per person is the average rate of change. How much the revenue is increasing up to that point. But what's going to happen afterwards? That revenue is going to start decreasing after that, because that's my maximum.